Okay, raw distance measures are highly influenced by the scale of the measurements. So we have to do normalizing. There are two ways of normalizing or standardizing. One is a z-score standardization where you subtract the from the observation the mean of that column and you divide by the standard deviation. So you get z-score. So the z-score can be a negative value or a positive value centered around 0. And there is another way of standardizing which is called range, where you subtract from the observation the mean and then you divide by the range. Range is maximum minus minimum of the column. So this transformation will transform the values between 0 and 1. So in either case, you're transforming the values of all the predictor variables to the same scale. So not one single column can have undue influence, unduly high influence uh, over the distance measure. So here are the two examples. I have done z-score normalization and the distance, the range normalization and the distance for the two companies that we randomly selected, Arizona and Consolidated. Okay, let's look at these computations in Excel. Okay, to do z-score normalization, we need mean and standard deviation of each column. So let's set up mean, okay, average of that, okay, and then we need standard deviation, and we need to use the standard deviation of sample.s, and so now we have the mean and the standard deviation. So let's copy this across. So now we have the mean and standard deviation for all the columns. Okay, so let's increase that. All right. Okay, so now we can set up the z-score for the two observations that we have randomly selected. So here is the x value minus the mean. Okay, so now we have to copy this formula down below. So I'm going to use absolute reference here. When you copy across the columns this way, the column should change. The mean of ROR is in column D, so column should change, the row should remain fixed. So this is the absolute reference that we need. No $sign for the column reference, but a $sign for the row reference, divided by the standard deviation. Again the same thing. You want the column to be able to change with copying and not the row. So that is our standardized value. For the first observation in the first column, copy that and across. So now we have standardized values using z-score standardization. So now we can do square root of sum xmy2. Okay, then that's your first row, first observation, and this is the second observation. So that will give us the x minus y squared sum and then square root. So that will give us the distance. So this is the standardized distance based on z-score standardization. And we can do the same kind of computation for using range normalization. For range normalization, we need range for each column. So that's max minus min. Okay, so now copy that. Alright, so now we are ready to set up the range normalization. So the actual value minus the mean. Okay, so mean is right here, and remember we need to have the row absolute referenced. Now this time we divide by the range, and once again the row must be absolute referenced. Okay, so now copy across. So now we can use this formula. We can just simply copy that formula down here, and we get the distance based on range normalized observations.